30.
All right. Yep, you got that right. Okay, so I'm just gonna quickly go over like the basic rules, right? So when you're adding two fractions, right, you have to make sure that these two bases are the same. Those are called your denominators, right? And then these two top numbers are called your numerators. So when adding subtractions, you want to make sure that the denominator is the same. And then you can just add the two numerators together while keeping the denominator, right? So then that would just look like 10 over 2. 10 over 2 is also equal to 10 divided by 2, which would equal 5. So that's a basic way to do addition, right? For multiplication, right, this problem right here, you just multiply everything together. So 36, right, is also equal to 36 over 1, because that's also the same as 36 divided by 1, right? 36 divided by 1 is still 36, right? So 36 over 1 times 5 over 6, you just multiply these by this. So 36 times 5 is going to be 0, 3. 5 times 3 is 15, plus 3 is 18. So you're going to have 180. And then 180 over 6 is going to be 30. So that's a really quick way to solve it. Okay. So Victor, can you tell me what's confusing about number 2 to you?
It's like it's not multiplication or plus or anything. It's like
You don't know what the sign is?
dividing.
Division? Yes, it is
Yeah.
division. Yeah. Okay. So were you at the class 2 weeks ago where I let's see. Do you remember this you remember this worksheet? No? Okay. I
No.
think you weren't here a couple of weeks ago. Okay. Oh, that's a little problematic. Okay. Let's go through this then together. All right, so a fraction is a numerical quantity that is not a full number, right? So a fraction represents part of a bigger number. So if I give you a number such as 1/2, right? This is part of 1, right? So it's not a full number. And then this sign right here tells you that it's a fraction, right? So what we were working with earlier in the warm-up was a fraction. Okay, so let's go through this real quick. So again, real quick, a fraction, look at these two parts, right? The circle right here is going to be called the numerator. The box right here is going to be called the denominator. Now, to convert from proper to improper fractions, you need to make sure that you can recognize whether this is a proper or an improper fraction. So when you look at the fraction, if the numerator is greater than the denominator, then it is going to be an improper fraction, right? But when the numerator is less than the denominator, then it's going to be a proper fraction. So if we go through all of these real quick, 1 and 1/4, right? 1 is going to be your numerator, 4 is going to be your denominator, and the numerator is less than the denominator. So let's go back to our rule. When the numerator is less than the denominator, that means that this is a proper fraction. And then this is 2/5. That's also going to be a proper fraction because the numerator is less than the denominator. We look at 6/7. 6 is also less than 7, so that's also a proper. Number 4 is improper. That's because the numerator is actually bigger than the denominator, right? 20 is greater than 5. 66 over 3, 66 is greater than 3, so that's also improper. So this last one, can you help me, Victor? Is this an improper or proper fraction?
Improper.
Why do you say improper?
Because the up is like bigger number than down.
Okay, show me which number is bigger. So if I wrote the fraction out, it would look like this. It's called a mixed fraction, where it has a whole number and a fraction, right?
Yeah.
So why would this be an improper fraction?
Because the smaller number is on top.
The smaller number is on top. So what is the smaller number?
2.
Right. So if 2 is less, what is the bottom number?
3.
Right. So if 2 is less than 3, what is the 2 called? Is it called the numerator or the denominator?
Numerator.
Right. So then the 3 is called the denominator, right? So would you say that 2 is less than 3?
No.
Really? So if I have 2 cookies and my friend has 3 cookies, I have more cookies than my friend?
No.
Right. So that means 2 is less than 3, correct?
Yeah.
Right. So if 2 is less than 3, that means our numerator is less than our denominator, right? So then what is this number? Is it an improper fraction or a proper fraction?
Proper.
Right. Okay. So there you go. That's how you look at it, right? When you have a mixed fraction, you just look at the fraction here instead of looking at the whole number and then getting yourself confused. All right. Hey, Molly. Hey, Ivanka. Sorry. Kind of reviewing some material with Victor because he wasn't here earlier. Glad you guys could make it for the last lesson today. Molly, if you could turn on your screen, that'd be nice. Thank you. All right, we're gonna move on to lesson 4. Sorry, Victor. I think we'll just go over a couple of these questions so you'll get a basic understanding of what I'm talking about here. All right. Ivanka, you want to help me with this problem? How do I solve this?
Actually, I wasn't really. Wait, are we doing lesson 4 today?
Yes, today is lesson 4. This is a review of lesson 3. So my friend last week was unable to teach this lesson, so I'll be teaching it with you guys today for the last lesson.
Oh.
So you should already know how to do this, unless you didn't take notes.
Wait a minute.
5 over.
Oh, right. So 5. Basically, 3 out of 2 can be changed to its reciprocal, I think. So
That's right.
that would be 2 out of 3.
Okay, so then what do I do here? What do I do now?
Change the sign.
2.
Multiply.
Good job. Nice.
And then you basically do the multiplication, which is 10 out of 6. And that's the answer, I think.
Yep, that's the answer. Good job. Okay. All right, good job. Make sure you write that down in your notes, okay? Because that should be very easy, very easy thing to remember. It'll be very helpful in the future. Anyway, okay, let's go over this problem. Looks like you guys need a bit of a recap. So, right, these two fractions, let's look at the denominator. If we're adding them, then they have to be the same denominator, right? But 2 and 7 are not the same number. So we gotta combine the numbers so that they have the same denominator. So we're gonna multiply the denominator and the numerator by the same number so that it's still the same fraction, right? I'll get 70 over 14. And then we'll do it the same on the other side, except we'll multiply by 2. So then this side ends up with 14 as the denominator as well, right? So we do 2 times 6 over 2 times 7, and we get 12 over 14. So now we have 70 over 14 plus 12 over 14. And okay, we just lost Victor. Okay, anyway, our answer is going to be 82 over 14. Yep, there we go. Okay, let's go over this question. Two denominators are different again. This is subtraction, so it's the same thing as addition. The process is the same. So let's multiply this by 7, both the numerator and the denominator, so that it's still the same fraction. So we're going to get 7,000 over 21. And then we're going to subtract by 3 times 6 over 3 times 7. So then this is also the same denominator. So then we'll get 7,000 over 21 minus 18 over 21. And then we're going to get 6,982 over 21. So Ivanka, since I'm pretty confident that you know how to do multiplying and dividing by fractions, can you help me solve this problem?
Okay, so first, change, right. 5 out of 4 divided by 2, you mean like the whole number 2?
Yes. So, hold up really quick. So, let's say we want to make 2 a fraction, right? We want to make this a fraction.
That would be
So 2 divided by what equals 2?
1.
Right, 2 divided by 1 equals 2, right? The 1 rule.
So then it's basically 2 out of 1.
2 over 1, correct. So not 2 out of 1. The way you say that is called 2 over 1, or yeah, just 2 over 1. Okay. So now we can reset that problem as 5 over 4 divided by 2 over 1. So now do you know how to do the problem?
Then you have to change the 2 over 1 to 1 over 2, and then basically change the sign into multiply, and add the 5 out of 4. And that equals, and the answer is 5 out of 8.
Nice job. All right, good job. Molly, do you think you're confident in helping me with number 6?
I guess.
All right, can you help me?
Yeah.
What do I do here?
First, you can I guess you can make the denominator the same.
Do we have to do that for multiplication though?
Yeah.
Actually, no, you don't, right? So for multiplication and division, you can just go through with this. You don't have to change the denominators or the numerators for that matter. But when you're adding and subtracting, you want to make sure that the denominators are the same. So instead, when you're doing multiplication, when you're multiplying two fractions, you just multiply the first number's numerator by the second number's numerator, and then you multiply the first number's denominator by the second number's denominator. So what would this look like?
Can you say that again?
So I will multiply by the first number's numerator by the second number's numerator over the first number's denominator times the second number's denominator. So if I have 7 over 2 times 9 over 8, what will that look like?
7 times 9.
Okay, that's the first part. Then what do I do now?
Then you do 2 times 8.
There we go. Good job. Now where do I go from there?
I'm guessing you gotta figure out what it equals.
Well, of course you got to figure out what it equals, right? But how do I find out what it equals? Right? You can't have a fraction where you have x's in the middle, right? That doesn't look right.
No, that doesn't look right. Well,
Correct.
7 times 9 equals 63.
Okay.
And 2 times 8 equals 16.
There you go. Good job. Okay, so yeah, you just multiply everything together, right? Like if I just take this 5 over 2 divided by, no, sorry, not that. I'm gonna do times 3 over 2, right? I can just look at that really quickly and I'll say 5 times 3 over 2 times 2, right? And then 5 times 3 is 15 and 2 times 2 is 4. So then that'll be my answer. See, really quick.
Mhm.
All right, good job. All right, we're gonna start going through the next lesson today, and this is gonna be about decimals. So what is a decimal? Decimal is a number where its whole number and fractional part is separated by a period or decimal. So this is a decimal right here. And so anything behind like a decimal, no matter what number it is, this is basically representing like a fraction. Yes, Ivanka, go ahead.
My dad says that when he was teaching me about decimals, he said that decimals are equal to fractions and percentages.
Yes, that is also true. Yes, this can be written as a fraction or a decimal or a percentage. They're all linked. So let me just give it an example real quick. Ready? If I say 0.25, right? That's my handwriting's bad. If I say 0.25, that's a decimal, right? But I can also say that is 25%. Or I could also say that this is 1/4. Right? So if I have 25 out of 100, that is the same thing as saying I have, so like that's like, have you ever gotten okay, I hope you haven't gotten like a test score that says 25 out of 100, but you've seen like a score where it was like 100, let's say 100 out of 100, right? That'd be called 100%, correct? So like similarly, if I have a 25 out of 100, that would be 25%. You'll learn about that logic in the future, but for now, you don't have to really touch on that. Today, I'm just going to talk about how like decimals and fractions relate. So as I just showed here, 0.25 is equal to 1/4. So how did I figure that out? Well, let's go on to the decimal zero rule, right? So if you have any zero behind decimal integers, it will not affect the value of the number. So if I have 10.2, actually, I'll just use the examples here. 10.50000, right? That is also equal to 10.5. That might be a little confusing, right? Because if you looked at a number without a decimal, that'd be 105,105. Obviously, they're not equal, right? But since we have a decimal here, and then these 3 zeros are after all like integers, then that doesn't affect the value of the number because these are just placement holders. Now, if I had a number like 10.05, this number is included because there's still an integer value after it. But then this is also equal to 10.050. Notice how this 0 is at the end, it's behind the integer value. I'll go through that a little bit more in a little bit if you're still confused about it. Let's go over how fractions and decimals are alike. So notice how 8/10 can also be written as 8 divided by 10, right? So then how is 0.8 equal to 8 divided by 10? Well, to look at that, we need to look at the dividing by 10 rule. So whenever you have a whole number, let's say 5, right? Even though it's 5, right, it can also be written as 5.00, correct? Because I have the zero rule after the decimal, right? it's behind the last integer value and it's behind a decimal. So this doesn't increase the value of the number at all. So even if I have 5.000000, it's still equal to 5. Right. So if we look at that, if we have 5.0 and let's say we multiply it by 10, right? What does the 10 rule state? 5 times 10, what do I get?
50.
Right, 5 times 10 is 50, right? So a really easy way to get this idea, right, is 5.0, right? The decimal in 5, right? So this can also be written as 5.0. The decimal just moves that way when you multiply by 10. Every time you multiply by 10, it moves one, the decimal moves one place value to the right. Right? So then it'll look like this. And remember, since it's after an integer value, we can have an infinite number of zeros. So similarly to that, if I multiply 5, let's say I multiply by 5.000, this is still 5, by the way, and multiply that by 1,000, right? I'll look at the zeros, right? I have 3 zeros, so that means I'm jumping 3 tens, right? So then the decimal goes 1, 2, 3. It lands right there. So I get 5,000. Notice how the decimal moved from this position to here. So if you understand that, then we can understand decimals, right? Because decimals operate in the style of tenths or hundredths for that matter. So there are different place values in a decimal. So let me give you a fake number here. 1.2423456. So there's a really specific way that teachers might teach you to say this. I'm going to be very unprofessional and just say 1.23456 because in the future it doesn't matter too much. The only thing you really need to understand is the names of each place value. So if you guys could write this down in your notes, it'll be really beneficial to you. But that's all up to you, of course. So this, of course, if it's in front of your decimal, it's called the whole number, right? Because that's a whole number. And then this first value is called the tenths. So any number in this area can be described as that number over 10. That is the value that it represents. So notice how the 2 is here. And then this is the hundredths. The hundredths, that means that your denominator is going to be 100. And then that number will be represented there. And then 4 is going to be your thousandths. So that's going to be 4 over 1,000. And then this is going to be your 10 thousandths. And then that's going to be your 100 thousandths. I hope that makes a bit of sense, but yeah, so if I said so Molly, can you tell me which number is greater and why?
The 0.3.
So there, first of all, can you tell me how, like,
0.3 tenths.
Okay, that is actually a really good try. I'm proud of you for that. But notice how there's a 0 here, right?
Mm-hmm.
Right, but where's the 3? Is it in the tenths or is it in the hundreds?
Tenths. I knew it was the 300ths, but the 3 tenths looked the 3 looked closer to the 0 before the decimal.
I'm sorry? I don't really understand what you mean. Can you explain for me?
Well, the 3 and 3/10 is 1 0 closer to.
Right. So 3/10 would be 0.3, right?
Mhm.
So what would this number be then?
0. hundredths?
Yes, so the 3 is in hundredths, right? But then the weight.
And that's in thousands.
No. Okay, so remember how you said that this number was 3/10, right?
Mhm.
So if this 3 is what? So tell me, what position is this in? You said hundredths, right?
Yeah.
Yeah, so then wouldn't this just be 3/100ths?
Yeah.
Yeah, so that's, you see what I did there? Okay, so now let's look at this. What would this be?
3,000.
There you go. Good job. Okay, so now tell me, which number is bigger, 3,000ths or 300ths?
300ths?
Good job. Okay, so normally people will think, oh, 100, wait, yeah, they'll think hundreds is less than thousands, right? Because you think, oh, 1,000
That's
and 100.
before. That's the whole numbers.
Correct. Ivanka, raise your hand.
Do decimals have any ones?
What do you mean lines?
I
Like
said ones, like the ones place.
oh, ones. Right. So no. Look up here, right? It starts at the tenths. This is the tenths. This is the hundredths. This is the thousandths. This is the 10,000ths, and it keeps going on and on. There's no one spot after the decimal, right? The one spot is right here. That's before the decimal, correct? So I think that should clarify a bit. But yeah, really proud of Molly for getting that question right. Because most people will think that 300ths is less than 3,000ths, but again, 300ths can also be written as 3 over 100, right? We've gone over this. And 3,000ths can also be written as 3 over 1,000. And obviously, this is going to be bigger because if I gave you 3 out of 100, that's going to be a bigger piece of a pie than it will be 3 out of 1,000. That is the same as saying I'll give you half of the pie and I'll give you 1/20th of the pie. So if I divide a pie by like 20 sections, right? And I just gave you this one little piece right here. Would you rather have that one little piece or would you rather have this whole piece right here? Obviously, I'd rather have the whole half piece, right? So that's why half is greater than 1 over 20. That's the same concept over here. Since this denominator is actually smaller, and the numerators are the same, then that means that the number with the smaller denominator is actually going to be greater. Okay, let's go on to this exercise. So now we're going to convert decimals to fractions. So can anyone help me? This is a really easy fraction to convert. So can anyone help me here? Yeah, go for it.
Me?
Yes, you.
Oh, so the 2 could be converted into 100 or 10 or whatever.
Which not? Hold on. That's a good start, but which number is closer, 10 or 100?
100? I mean 10.
Yeah. So never go further than you have to, right? Because
Oh,
why would you go all the way to 100? Then you have to do more multiplication, right? Okay.
yeah.
Well,
So basically that would be 5 out of 10. And to convert it into a decimal, that would be 0.5.
right. I didn't really get your explanation, but you got the right answer. So what I would do is, so obviously this number is less than 10. So that means that I can easily just convert this to tenths, right? So I can just look at this and say, wow, I want this denominator to become 10, so I can put it in tenths. So if I multiply the bottom by 5, that'll get me 10, right, on the bottom. But if I multiply by the bottom by 5, what else do I have to do to the top? I also have to multiply by 5. So then I'm going to get 5 tenths. Now 5 tenths, 5 tenths, right? I divided by 10. So then the decimal moves back a position. So I get 0.5. Right, so that's a really easy way to find. Also, this should just be like in your memory. Like this is a really simple fraction. 1/2 is 0.5. All right, let's go over the next question. 3/2 to a decimal. So again, we have the 2, right? So we know that this can be converted to tenths. So if we multiply 2 by 5 to get 10 on the bottom, we also need to multiply 3 by 5 to get 15. So now we have 15/10. Well, you're going to say, whoa, it's an improper fraction. What do I do? Well, we already learned how to convert improper fractions to proper fractions, right? So then we're just going to say 15 divided by 10. 10 goes into 15 once, and then we get 5, right? So our remaining improper fraction, our proper fraction is going to be 1 and 5/10. Right? And then from there, we have our ones value, right, that you were asking about earlier, Ivanka. And then we have the decimal, and then 5/10 is also equal to 0.5. So our answer is going to be 1.5. Did you have a question there, Ivanka, that I missed?
No. I had the answer, not the question.
All right, cool. Let's go on to the next question here. So real quick, 8/10, that is equal to 0.8, right? So I have 8.0, and then we divide by 10, right? The decimal moves back one, so I get 0.8. Three over 5, the closest number to 5 is 10, right? So I'm just gonna convert the denominator to equal 5. So to do that, I multiply the denominator by 2, so I'll get 10, right? And then the numerator also has to multiply by 2, so I get 6/10. And 6/10, 6.0, move the decimal back 1, so I get 0.6. Oh. Okay, we're going to quickly move on to quickly move on to adding decimals. So when you add decimals, it's the same thing as addition. Nothing changes, except you want to make sure that you're aligning the decimal spots. So I can't. So if I look at this example right here, right, 10.6543, I can't do this. Why? Because look at the two decimal spots. They're not aligned, right? So you might be wondering, what do I do then? Well, remember the 0 rule after integer values for decimals? How 0.10 is also equal to 0.1, right? So if you feel really uncomfortable that you have no numbers after this one, right? So if I line up the problem, I can just add 3 zeros at the end, right? Because this doesn't change the value of the number. Or in your head, you could just say that you're adding 0 where there's a blank spot, right? But essentially, you have to have it lined up for it to work. So real quick, I'm going to take 1.2 plus 3.6. 2 plus 6 is 8. Remember to pull your decimal down. 1 plus 3 is 4. So my answer is going to be 4.8. And then I'm going to go through this problem real quick. 9.434. Subtraction is the same thing, right? You just have to line up the decimals. Now that they're aligned, I don't know what to put here because there's nothing, so I'm going to put a 0, right? That's going to be our placement value. 2.120 still equals 2.12. So now we're just going to subtract like I would in a normal problem. 4 minus 0 is 4. 3 minus 2 is 1. 4 minus 1 is 3. Pull down the decimal. 9 minus 2 is 7. That's going to be my answer. Okay. Finally, we're going to go over multiplication. So this is particularly hard. Unlike addition, you do not have to align the decimals. So if I have a question like this, wait, they have the same. Never mind. If I have a question like this, first I'm gonna put the one with like more numbers. So 33.21, and then I'm gonna multiply by 44.2. This doesn't change. The number with more numbers is going on top. But you might be wondering, how do I know how many decimals I end up when I finish multiplying, right? So to do that, you just look at the number of decimals in the first number. That's going to be 2, right? I have 2 decimal spots. And then in the second number, I only have 1 decimal spots. So now if I add those together, I get 3. So my answer is going to have 3 decimal spots. So now let's just do multiplication. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 3 is 6 again. And then 4 times, so I'm going to put a 0 here. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. Put the 1 here. 4 times 3 is 12 again. So plus 1 is going to be 13. And then I'm going to multiply by 4 again. So 2 0 places. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. Put the 1. 4 times 3 is 12 plus 1 is 13. So now I'm going to add everything together. So 2 plus 0 is 2. 4 plus 4 plus 0 is 8. 6 plus 8 is 14. Plus 4 is 18. Put the 1. 6 plus 1 is 7. Plus 2 is 9. Plus 8 is 17. 1 plus 3 is 4. 4 plus 2 is 6. 1 plus 3 is 4. And 1. So now we basically have our answer, right? But you're not done yet. Because notice how our number is in the millions. I don't think So a really easy way to see if you did the decimal right is just to check. So 33 can be rounded down to 30, and 44 can be rounded down to 40. So if I multiply these two numbers together, I get 1200, right? So my number should be somewhere around 1200, or at least it should have similar to this many placements in whole numbers. So again, we can follow the rule that we just did up here. So our answer is going to have 3 decimal spots, right? So I'm going to go 1, 2, 3, and that's where my decimal spot's going to lie. And then we can do a real quick check. There's 4 whole number spots, right? And I have 4 whole number spots here. So that's how I know it's correct. We can quickly go into our calculator and do 33.21 times 44.2. And we get 1,467.882. So that is the answer that we have down here. Okay. Just going to quickly go over the last few questions, and then you guys will be off for the rest of the day. So let's just get rid of this real quick. Hey, Molly, can you help me with this question, please?
Yeah.
All right, go for it. What do I do first?
Don't you have to like times don't you have to put it like up and down?
Yeah, so this is still like normal multiplication, right? At least setting it up. I put the number with the most amount of numbers on top, right? So since these are the same, what do I do? I put the bigger number on top. So which number here is bigger? 0.65 or 0.23?
0.65.
Great. So now what do I do?
Then you put 0.23 underneath.
Okay, good job. Now what do I do?
You do 5 times 3. That's 15. And then 6 times 3. That's 18 plus 1 equals 19. And 3 times 0 is 0, but plus 1 is 1.
Right?
And then 2, oh, you gotta add a 0 under the 5.
Nice.
Then 2 times 5 is 10. You put right. And then 2 times 6 is 12. Plus 1 is 13. 2 times 0 is 0. Plus 1 is 1.
Okay.
0 times 5 is 5. What? No.
Family bike riding.
0 times 5 is 0. 0 times 6 is 0. 0 times 0 is 0.
I finished or not?
No.
All right, we'll be finishing up soon. I know your parents a little rushed. Okay, so let's add everything together. We're gonna get 5, 9, 4, and 1, right? So now where do I put my decimal?
I guess you dragged it. It's behind the 4.
Okay, that's a good guess. So again, let's look at how many decimals are in both of these numbers.
1.
Sorry, how many decimal spots are there in each number?
2.
Correct. So now, so when you're multiplying two decimals together, your final answer is going to be equal to the amount of decimal spots of one number added to the other number. So we're going to have 4 decimal spots in our answer. So if we have
So
4 decimal,
0. So 0.